All right, let's get right into it. We're going to pull back the curtain on the tech that's behind all the stuff you're probably using. ChatGPT, Gemini, Claude. We're going to unpack how it really works.
I mean, you've probably experienced this, right? You type in a question, anything at all, and bam. A second later, you get this incredibly coherent, sometimes brilliant answer. It's just wild. So, how does it do that? How does it know what to say?
It's so easy to feel like you're talking to a person, right? Like there's a real mind on the other end. But what's actually going on under the hood? Well, it's a masterpiece of statistics, of just mind-boggling scale, and a core idea that's actually surprisingly simple.
So, to really get how these things work, we need to forget about all this sci-fi stuff for a second. Artificial consciousness, all that. Because at its heart, an LLM's primary job is to play a game. A really, really simple game. Guess the next word.
Okay, so here's the official kind of textbook definition. A large language model, or LLM, is just a type of AI that's been trained on a truly ridiculous amount of text. I mean, we are talking about huge, huge chunks of the internet. Books, articles, code, basically a digital library of humanity. And this is the single most important thing to understand, really. At its core, everything an LLM does, from writing a poem to debugging code, it all boils down to one simple repeated action, predicting the most likely next word in a sentence. That's it. So think about it like this. If you give it a phrase like, I like to eat, the model just looks at all the patterns it's learned from all that data, and it calculates, okay, what's the most probable word to come next? Maybe it's sushi, or pizza, or ice cream. It picks one, let's say pizza, and tacks it on. Now the sentence is, I like to eat pizza. And then it just does the exact same thing again for the next word. Over and over. That is the entire game.
Okay, so you might be thinking, wait, if it's just a word-guessing game, how is it so powerful? How can it write code or explain quantum physics? Well, that's where the two key ingredients come in. These are the things that took this from a simple party trick to, well, world-changing technology. Let's get into them.
Think of it like a recipe. You need two main things. First, ingredient one, data. And I mean a colossal amount of data. More text than you could possibly read in 1,000 lifetimes. This giant library is what teaches the model all the patterns, the grammar, the facts, and yeah, even the biases of human language. And then, ingredient two, the architecture. This is the blueprint, and the big breakthrough here was a design from 2017 called the Transformer.
And what's just absolutely wild is the speed of all this. The key breakthrough, that Transformer paper, that only came out in 2017. Then you see this rapid-fire progression. First BERT and GPT-1 in 2018, then GPT-2 in 2019, which started to get people's attention. And then boom, by 2022, we have ChatGPT and it's everywhere. We're talking 5 years from a niche research paper to a tool used by hundreds of millions of people. That's not a slow burn. That's a straight-up explosion.
And just to give you a sense of the scale we're talking about, look at this number. A big model, like Google's Palm, has 540 times billion parameters. So what's a parameter? Just think of them as tiny little knobs and dials inside the model's brain. During training, it's constantly tweaking all 540 billion of those knobs to get better and better at predicting the next word. With that many knobs, it can learn incredibly subtle, complex patterns in human language that we can't even describe.
All right, so we've got this incredibly powerful next word predictor. But that doesn't automatically make it a helpful assistant, does it? A raw model, right after it's been trained on all that internet data, is kind of like a stochastic parrot. It's just brilliant at mimicking patterns, but it doesn't really understand what you want. So, how do you go from a parrot to a real partner? And this is a really, really crucial problem. For example, if you tell a raw, freshly trained model, write an essay about Hamlet, it might just complete that sentence with something like, is due by Friday for grading. Why? Because it's seen that pattern a million times in its training data. It doesn't get your intent. It doesn't know you want it to be the student, not the teacher giving the assignment. This is where the real fine-tuning, the real alignment work has to happen. So the whole point here is to move beyond just predicting words. The goal is to align the model with what humans actually find useful. We want it to be helpful, to be honest, and, to be harmless. And luckily, there's a very clever technique to do just that. It's a bit of a mouthful, but it's called reinforcement learning from human feedback, or RLHF for short. And honestly, this is the secret sauce. This is the process that turns a brilliant but clueless parrot into a helpful assistant.
It's basically a training phase where humans come in and act like teachers, showing the AI what a good answer actually looks like.
So here's the simplified version of how it works. Step 1, a bunch of human trainers are given a prompt, and then they get several different answers generated by the AI. Their job is just to rank them from best to worst. This one's great, this one's okay, this one's terrible. Simple enough. Step 2, all that ranking data is used to train a second, totally separate AI. We'll call it the reward model. And its only job is to learn to predict which answers the humans will like the most. It's learning to have good taste, basically. And then for step 3, the original big LLM is fine-tuned with a new goal: generate answers that get the highest possible score from that reward model. It's kind of like training the AI to impress its little AI coach, who's been trained by humans.
So when you put all of this together, the massive data set, that powerful transformer architecture, and this human feedback loop, something truly fascinating starts to happen. The models begin to develop skills they were never explicitly trained for. These are called emergent abilities, and as we'll see, they have some pretty amazing and some pretty serious real-world consequences. I mean, these skills just sort of appear out of nowhere. Once a model gets big enough, it suddenly gets good at stuff like basic math or logical reasoning, or even unscrambling jumbled words. One of the most famous examples is chain of thought reasoning. It turns out if you just tell a big model to think step by step before answering a complex problem, it gets dramatically better at solving it. Nobody programmed that in. It's just a strange, powerful byproduct of massive scale. But, of course, a technology this powerful is going to come with some powerful challenges. It's not all sunshine and emergent abilities. The very things that make these models so incredible, that huge, unfiltered data set and their complex kind of black box nature, are the exact same things that create some pretty significant real-world problems. I mean, just think about it. The models learn from the internet, warts and all, so they can pick up and even amplify all of our worst stereotypes and biases. Sometimes they just flat out memorize and spit back copyrighted material. Their safety features can be tricked with clever prompt injection attacks. And the sheer amount of electricity needed to train one of these massive models is just enormous. These aren't just little bugs to fix. They're fundamental challenges baked into the very design of this technology.
So where does that leave us? We've seen that it's not actually magic. It's a prediction engine running at a scale we can barely comprehend that's then been carefully fine-tuned based on human preferences. But the big question remains: is it just a really, really fancy tool for arranging words, a sophisticated text manipulator? Or are these emergent abilities, these unexpected skills, the first real sparks of a completely new kind of intelligence? Honestly, that's the billion-dollar question that we, as a society, now have to figure out.